In this video, we will solve the sixth question from Mechanical Engineering first set of question paper conducted in GATE 2019. The question is, the natural frequencies corresponding to the spring mass system 1 and 2 are omega 1 and omega 2 respectively. The ratio omega 1 by omega 2 is. So this is system 1, system 2. They are having the same spring constant K, and K, and they are having the same mass capital M and capital N. We have to find the ratio of natural frequency of system 1 and system 2. The options are 1 by 4, 1 by 2, 2, 4. You can also refer to the NPTEL course Mechanical Engineering, Mechanical Vibrations coordinated by IIT Guwahati. Before going to the video solution, let's see some useful data. When two springs K1 and K2 are connected in series, then the resultant spring constant is given by 1 by K equivalent equal to 1 by K1 plus 1 by K2. When two springs are connected in parallel, then the resultant spring is given by K equivalent equal to K1 plus K2. I'll be explaining about these formulas in the video solution. As we said earlier, when two springs are connected in series, let this be one K1 and this be K2. This is just I represented it as a joint, and these two springs are K1 and K2 are connected in series to a mass M. Okay, let us suppose there is a force F is acting on this capital on this mass M. Okay, therefore, when a force F is acting on mass M, there will be displacement x1 on spring 1 and there will be displacement x2 in spring 2. Since they are connected in series, we can't say that their x1 and x2 displacement will be same. But we'll assume there is another equivalent spring K equivalent which is attached to the same mass M, and we are applying the same force F. Then the extension, then the elongation of the spring will be X equivalent. And from here we can say that X equivalent is nothing but the x1 and x2, comparing these two, because we are assuming K equivalent is the effective spring constant of K1 and K2 when they are connected in series, and their displacement, then their elongation will also be the summation of these two, x equivalent equal to x1 plus x2. But we know that F equal to Kx, therefore x equal to F by K. Fine. So here x equivalent is F divided by K equivalent, and x1 will be the force on this K1 will be F, and force on K2 will also be F. So x1 will be equal to F divided by K1, where K1 is a spring constant of 1 and x2 will be K by K2. Since the F is common, we can cancel F. Hence, for a series connection of spring constant, for a series connection of springs, the effective spring constant K is 1 by K equivalent equal to 1 by K1 plus 1 by K2. Okay. For a parallel connection, this is K1 and K2, and we are applying a force F. But the force experienced by K1 is not F, and similarly force experienced by K2 is not F. It is force F1 and a force F2, and F1 plus F2 equal to the total force F. Similarly, if you are assuming into an effective spring K equivalent connected to a mass M, and this mass is elongated by the force F, then here K equivalent into X equal to F. This will be the elongation of this spring. Since they are connected in parallel, the elongation of K1 and the elongation of K2 will be same. That is, the elongation is X. Okay. Therefore, F1 is what? K1 into X, and F2 is K2 into X, and the F is K equivalent into X. Therefore, cancelling X, we got K equivalent equal to K1 plus K2. Okay, that's it. And now we'll come back to the question. In our question, it is given as K1 equal to K2 equal to K. So 1 by K equivalent of the first one, that is, let us represent it by S series, equal to 1 by K plus 1 by K, which is nothing but 2 by K. Therefore, K equivalent of series is K by 2. For here, K equivalent for parallel connection is K1 plus K2, right? K1 and K2 are same, which is K. So, K plus K, which is nothing but 2K. Okay. Then the natural frequency is given by natural frequency omega is given by under root K by M, where K is the stiffness of the system and M is the mass of the system. Okay, we have said that it is said that omega 1 is a natural frequency of system 1. System 1 is series connection. Therefore, omega 1 is nothing but under root of K equivalent divided by mass M. K equivalent is K by 2 divided by mass M. Therefore, omega 1 equal to K by 2M. Okay. And now for parallel connection. For parallel connection, it is represented by omega 2 of system 2, which is nothing but under root of K equivalent by M, which is nothing but K equivalent of parallel. Okay, K equivalent of parallel is 2K by M under root. Okay. Next, what we are asked to find is omega 1 by omega 2. Is nothing but omega 1 is what? Under root K by 2M divided by under root 2K by M. So mm cancel, kk cancel, will get under root 1 by 4. Okay, therefore omega 1 by omega 2 is under root of 1 by 4 is 1 by 2. Therefore, the answer is 1 by 2. Therefore, for the sixth question of Mechanical Engineering first set of GATE 2019 question paper, the answer is 1 by 2. The ratio of omega 1 by omega 2 is 1 by 2. For more reference and clarification, please refer to the NPTEL course Mechanical Engineering, Mechanical Vibrations, coordinated by IIT Guwahati. Thank you.